Differential Equations Section 2, Analytical Solutions. Video 4, Worked Example. We're going to work through an example now, and we're going to split this over two videos. So here's the question that we're going to look at. For the differential equation dy by dx equals y minus 2x, first of all, state the asymptote of all the particular solution curves. Secondly, find and sketch a particular solution that is an increasing function and a particular solution that has a stationary point. And then finally, show that the particular solution through 0k has a stationary point if k is less than 2. So in this video, we'll look at the first two parts of this question, and then in the next video, we'll look at the last part. So for the first part, we're given the differential equation dy by dx equals y minus 2x, and we've been invited to state the equation of the asymptote for all the particular solution curves. Well, let's start then by solving our differential equation. So we had dy by dx equals y minus 2x, so I want to solve the ODE, and dy by dx, so y dashed equals y minus 2 times x. And it gives me the solution y equals c1 e to the x plus 2x plus 2. Now I can click on that in order to plot it in my graphics window. Just going to zoom out a little bit there. And I can add in the slider for c1 so that I can vary the constant and see these as a solution family. Now, in terms of an asymptote, it looks down here as if the curve is starting to approach a straight line regardless of the value of my constant c1. So I need to think about what that asymptote might be. Well, looking at my equation, I've got y equals c1 e to the x plus 2x plus 2. I can see that as x tends to negative infinity, the e to the x term is going to become vanishingly small. So it looks as if this curve is going to tend to y equals 2x plus 2. So let's plot that on our axes, y equals 2x plus 2. And I'm just going to select that line, and I'm going to make it a dotted line just to make it a bit clearer that that is the asymptote. Okay, so I might want to write down the solution of the differential equation y equals c e to the x plus 2x plus 2. I've only been told to state the equation, but I might just want to write down that as x tends to negative infinity, y tends to 2x plus 2. So the line y equals 2x plus 2 is an oblique asymptote. Now the second part of the equation asks me to find and sketch a particular solution that is an increasing function and a particular solution that has a stationary point. So I need to look at when the solution is increasing and when I get a stationary point. Well, it looks as if for all of these positive values of c here, I'm getting an increasing function without a stationary point. When I have the case c1 equals 0, I'm just getting my asymptote line there. And then for negative c1, it looks as if that's when I'm getting my stationary point. And so what I want to do then is I want to pick a couple of sensible values and use them for my sketches. So I might want to pick c1 equals negative 1 for one of my sketches and c1 equals 1 for my other sketch. So here are my two sketches. This was the case where my constant c was equal to 1, and this was where my constant c equals -1, and my general solution there was, just to remind you, y equals c e to the x plus 2x plus 2. And note that I've put my asymptote on here as a dotted line as well, just to help me with my sketch really, and to see the different behaviours that are going on in the two different cases. Notice that for the case c equals 1, the curve is always above the asymptote, and for c equals -1, the curve is always below the asymptote. In this video, you've learned how to find and sketch solutions to differential equations.